all get reminders actually? I had set the reminders yesterday and then for 1 hour and all that, like. Okay. I'd set it for a day for an hour and then for 10 minutes actually. We'll start the stream actually. There could be people joining there. Welcome. In a few minutes from now, we will be starting the webinar. I find a few people from CDAC also, Ranu, Thanavi, they can actually, if they want, they can introduce themselves. Anyone that you know of, madam? Yes, madam, Runu Tantwe. You can actually introduce yourself. We're just waiting for the program to start. Your mic is on mute.
Is it audible, sir?
Yes.
Hello.
Yes.
Good evening, everyone. So, I am working for Gyanam School of Business. So, there, basically, I'm teaching information systems. So, I got to know about this webinar from Sir, the director of Gyanam. So.
Oh, okay. Okay. Mr. Sundar gave this invite to you.
Yes, sir.
Oh, okay. Welcome, madam.
Thank you, ma'am.
Yeah. We'll be on mute till the proceedings start and yeah. Yes, anyone outside RANE group, you can introduce yourself. Actually, Mr. Sundar has circulated with the Gyanam School of Business. I think a lot of people have joined from there. Yes. Mr. Ruben Benedict, he is from which organization? Mr. Ruben Benedict, you are from which organization? Is my voice audible? Yeah.
Yes, madam. Yes, madam.
Yeah. Can you introduce yourself? Mr. Ruben Benedict is one name I'm not very familiar with. You're coming from which organization? Mrs. Parvadam. Mr. Shankar Murugesan. You are from which organization, sir? Shankar Murugesan. Unmute, please unmute and speak.
Hello.
Yeah.
I think I am audible now.
Yes, please.
Yeah. Good evening, madam and organizers. I am Dr. Murugan, working as HOD mechanical in Government Polytechnic, Trichy.
Oh, wonderful.
Tuvakudimalai.
Okay.
I received an invitation through my friend working in RANE. And
Okay.
as the topics are very interesting, I thought of joining this, and I am now in this program.
Oh, thank you so much.
Thank you organizers for organizing such a wonderful webinar. Thank you very much.
Thank you so much, sir. Yeah. I think people are joining. We can start with the welcome address, Dr. Joshua, and I'll keep admitting people in so that we are on time. You can start the live streaming also. Yeah.
Thank you. Thank you, Dr. Joshua. It's a pleasure being with all of you this evening. I think it's nice to be in the midst of so many teachers. I think most of you teach in different contexts in management schools and engineering colleges and polytechnics. And I'm delighted to know about this the series of webinars, which has been conceptualized by my colleague, Mrs. Rajalakshmi and Dr. Joshua. And they're delivering it from RPTC to the teaching community, mainly to benefit the teachers and students. Some of these are in the space of, first is about the IoT, we call as Internet of Things. And second one is on designing for reliability. And third is about what's going on with 5G and its impact on businesses. All are very, very contemporary and very important themes for us. And coming as I do from industry, it's important that both the teachers and the students from the different engineering colleges have a very good understanding and good insights about some of these themes, which are emerging themes and contemporary themes, very relevant in the space of teaching and in the space of real work. So I'm really pleased to be here in your midst for a while. And I also thank Dr. Janet for accepting the invitation from the RANE Polytechnic and agreeing to deliver this today, and to the two other faculty members also. I'm sure that you'll all, surprisingly, all the teachers are very quiet today with the mic switched off, and they haven't been loud enough to introduce yourselves. But in the real life context where I've seen, I think it would be a very noisy place if 45 plus totally, I see there are 47. If 47 teachers are there, it's not going to be a very quiet place as it is today in an online platform. So please feel free to interact and make it an interactive session after the formal part of the presentation is over. I think it'll be mutually beneficial to everyone if you make it very interactive. So with this, I once again invite all of you to this program, and please attend the other two also and interact freely. I thank the team, RANE Polytechnic, who have designed and are going to deliver this. Also the students who are going to be participating through the webcast to kind of learn whatever they can and interact with the students. And thank you, Dr. Janet, for kindly agreeing to be the faculty today. Thank you, Dr. Joshua. Please go ahead with this. Thank you.
Thank you, Dr. Joshua. It's my proud privilege to introduce the speakers of today's session. The short profile is going to take about 2 to 3 minutes because it's quite impressive and long. Dr. Janet serves NIT Trichy. NIT Trichy has always been the symbiotic support of all colleges in and around Trichy, helps us with MOUs and all the latest in the field of technology all the time. So Dr. Janet serves NIT Trichy as Assistant Professor in the Department of Computer Applications. She graduated in BSc Physics with distinction from Holy Cross College, Trichy, affiliated to the Bharathidasan University, Trichirappalli, obtained a Masters of Computer Application from Bishop Heber College with a 3rd rank from Bharathidasan University, Trichy. She cleared the NET for lectureship by UGC in 2001. She started her research in information retrieval with a first class and Master of Philosophy in Computer Science from Aragappa University, Karaikudi, and a PhD degree by the NIT Trichy. Dr. Janet has set up the first of its kind information processing and security laboratory at NITT with industry involvement. She has also set up a honeypot node as part of National Cyber Coordination Center project, funded by MeitY and implemented by CDAC Mohali for cyber threat intelligence generation. She is the coordinator of the IoT lab of the Siemens Center of Excellence in Manufacturing. She is a champion of open source community. She has published more than 60 research papers in international journals, conferences, and book chapters of repute in the field of data science. She has been a professional facilitator of students. Her teaching experience includes experiments on activity-based learning, learner-centric teaching, and flipped classrooms. She has visited Malaysia to present one of her research papers in a conference. She is also a reviewer for international conferences and journals. She is presently the life member of Computer Society of India, International Association of Engineers, ISTE-ISC, and International Association of Computer Science and Information Technology. She is also an active senior member of IEEE and a professional member of ACM, The last line is of interest for all the other Polytechnic colleges. You can invite her as a speaker if you hold webinar series as well. Thank you for listening to me, and it was a very impressive biodata. I welcome Dr. Janet to the webinar, and it is on Internet of Things, the topic of interest of today. Thank you.
Thank you very much, ma'am. Hope I'm audible.
Yes.
Hope I'm audible. I will share my screen now.
Okay.
Can you see my screen?
Screen is not seen. You're seen, actually. Yeah.
Is the screen visible to everyone?
Yes, madam. Yes, madam.
Yes, madam.
Good evening, everyone. I'm Janet from the Department of Computer Applications. Thank you very much for inviting me to give a talk on Internet of Things. As a data scientist or someone who works
எனக்கு
with
screen
data,
வரல. அவங்க screen வரல share பண்ணுது.
yes, as a person who works with data, I thought that I could walk you through what is Internet of Things, and from a learning perspective and from an intelligence perspective, how Internet of Things is making a deep impact in various facets of our human life. If you look at our daily life, right from the time we get up from our bed to the time we go back to bed, there are a lot of things that we use, and some of them would be connected knowingly or unknowingly. And all of us have a cell phone. Our cell phone has a lot of sensors in them. I have listed a few of the equipments. Maybe we will not be using them, or we will not be aware of how these equipments have sensors attached with them and how they become things that are connected to the internet. But your refrigerator, your printer, your microwave, those are all devices that we have at home. Our computers, especially during this COVID time, when you look at those devices, all these devices are being connected, and we have been exploiting them to a maximum extent. And knowingly or unknowingly, Internet of Things has become a part of our life. It is not a recent topic. It has been there for more than 20 to 30 years, but people have been working on it. People have been trying to improve it, and due to certain reasons, it was not widely accepted. But now, due to the COVID situation, we have been forced on to the Internet of Things. Okay, so some of the things would listed here you would have used in whichever way you want. Can I see a chat message saying listing any one sensor that is found in your smartphone? You know, when you think about Internet of Things, we always think about sensors that are attached to our phones, and how these sensors are trying to give out some information. Internet of Things, and these things we normally say that it is a sensor or a device. That was my understanding so long. Okay, can I see a chat answer of some of the sensors? Thank you, Malkia. Gyroscope sensor. Okay, anything else? Any other sensor that you can find in your smartphone? Proximity sensor. Thank you, Jagadish. GPS. Thank you. So you have a lot of sensors that come automatically on your cell phone, okay, on your smartphone or your mobile phone. Now these sensors are getting some information, and either knowingly or unknowingly, with our permission or without our permission, sending these information somewhere. Okay, so when you look at it, if you look at a smart home, normally in an IoT environment, we say it is smart. So we call it a smart home, we call it a smart city, we call it a smart industry or a smart factory or a smart shop floor. anything that becomes smarter, a smart refrigerator. So there will be certain devices around the basic device that will collect some information, use the data in order to make the information more smarter. Okay, so you see a power plug, a weather sensor, a smart light that switches on once it is dark outside, a smoke detector that can raise an alarm, and if the data is properly being used and connected, it can even give a call to the fire station in order to get the people there. Okay, and there is a motion sensor to detect if any unknown person has entered into the house when there is no one inside the house, a smart gateway, a vibration sensor. There are hundreds of devices that you can connect on. These are all small sensors that are all connected together in order to do something that will make the house function better. And it is not only these electronic devices, these electrical devices. If you look at civil, they have self-healing material. Plasters on the wall, concrete that can heal by itself, so that if there is a crack, the crack automatically fills itself. And this is called nanoscience. So different areas have been expanding from the basis of collecting data, using the data and making it do something which it cannot do. How is all this possible? This smart home has been expanded onto IoT-enabled factories, where factories have used robots, and now they call it cobots, which work along with a man. A man and a robot working together, we call it a cobo. And this factory system itself, the shop floor itself, has a lot of sensors attached with it. The warehouse and all the accessories attached with the factory, they have a lot of sensors, and these sensors gather in a lot of data. The data is being processed and the data is being used in order to make the factory work better. And it is not only in factory and industry. Of course, they started exploiting it first, and it slowly entered into the other arenas of life. You have the shops, the airports, stations. In your shop, you just walk into the shop. On either side, you have something that will open the door automatically. It is an Internet of Thing. It has a sensor. So when a human being enters into comes near the door automatically opens. And if you want to count the number of people who are entering into the shop, you just connect it to a small program, so that the program is able to count the number of shops. Okay, so what I want you to remember is that Internet of Things can be an independent device, or it can be connected to a program that will be a software, and the software would collect some data which can be used in order to make some meaningful decisions, or what in industrial terms we call it a data-driven decision. If you want to make a policy decision, we need to back it up with some kind of data in order to know that the decision that we take works. So for these data-driven decision making, Internet of Things has enabled a lot of changes. So we use that in airports, in public stations. We already saw that our mobile devices have been collecting data, helping with data that we use. Edge IoT devices that can collect data, have some memory in it, store it, and send it out. You have surveillance cameras present. These surveillance cameras have a small memory in it. The memory stores the data, and once it is done, it is being transferred onto some server where the data is being processed. So this, we call it as Edge IoT, where on the sensor, your camera is a small sensor that can capture pictures continuously, and that picture is not immediately transmitted. In certain cases, you immediately transfer them to servers. If it is on a highway, then it is collected and then it is transmitted together. Okay, so this we call it as Edge IoT devices. Simple IoT devices. These are said to be simple IoT devices, wherein you have a moisture sensor, a pressure sensor. On the field, agricultural field, you have a moisture detector for automatic watering of plants. So we have IoT devices that help with them. These are some of the places where it is used. Now we have IoT-enabled ships, airplanes, trains, cars on logistics for logistic industry. Since the path where the car or the truck travels is fixed, people use manless vehicles in order to do the traveling. And IoT-enabled cities, we are planning a lot of smart cities, homes and buildings in order to save energy, in order to increase security in an energy. We try to use IoT devices in order to make things easier and help reduce the number of people, so that the data from the IoT devices can be used in order to make meaningful decisions later. Now, for all this to happen, there should be a data center. And this data center is where all this data is being analyzed together and stored. If you look at Internet of Things, it has pervaded into every area of our life, formal, informal, even schools have cameras fitted now, surveillance cameras made mandatory in schools, and they have become under the surveillance. So once it comes under surveillance, it becomes an IoT enabled service or IoT enabled place. So smart schools, smart classrooms, smart shops, smart hotels, and we have anything that can have some computers, some devices in it becomes a smart place where we will be able to collect data. According to, as a data scientist, I will only look at what data do I get from it and how do I change the data, what do I perceive from the given data. So this IoT enabled factories, and if I have to say, this Internet of Things has helped in the big boom that happened over the artificial intelligence. You know, people were talking about AI, and they said that AI is something which is interesting. It has changed the way in which people work. A lot of jobs had been retrenched. And how is that possible? It is from the data that came out of all these IoT enabled services that happened for a very long time. Now, if you look at the structure of it, what are the levels with which the framework works? You have the physical devices or the controllers. We call it the edge, or the place where the sensor is placed. So they are called as the things in Internet of Everything. Internet of Things, you call it as Internet of Everything also. And the thing can be a small sensor device or anything that will gather data from the surroundings, and it has to have a connectivity either to a router, a switch, or to a gateway, and then it is connected to a data element analysis. It is connected to the edge, and through the internet the data is being accumulated on a data storage, and then the data that is accumulated is being abstracted, analyzed, visualized, and the visual representation of it is being used in various applications. So here we see the reporting, analytics, and controlling happen, and this layer helps us in making some decisions. Then we have the business processes with collaboration and various processes in them. The basis or the building block of your IoT devices are the sensors that gather the data, after which how you use the data is in the hands of the user. So the sensors send in streaming data that keeps coming 24/7, and it keeps flooding the data center, and we can use this data in order to get things done. What are the different data sources that we have? We have sensors, we have applications, software agents that keep automatically collecting data, like bots, individuals, organizations, hardware. And I've given you a small picture from the internet of what happens on the internet in a minute. So much of data is being aggregated on the internet. I would not say generated. Some of it is generated, some of it is re-sent, and some of it had been regenerated from what was already existing. So this is the amount of data that you have on the internet. Now, what do you do with this kind of data? You try to do some analytics on it. So what do? You try to perform various types of analytics. What exactly happened on it, do a query on it, or ask it a question and get an answer from it. Then you do some diagnostic analytics on it. I'm not going into the details of it because analytics by itself is a big subject where we can talk about it. If you are interested, you can study about it and try to understand how exactly the different types of analytics work. I will give you an example of what is prescriptive analytics alone, because that is the phase wherein we are now. So we use the descriptive analytics for a long time. We just query, do some operations on the data, and try to get some results from it. Then we try to diagnose what is the problem. We moved on to prediction, saying that this will happen, and we have to be worried about it. And this prediction is what we did in the previous 10 years. And now we are trying to do prescriptive analysis with the help of our learning algorithms. We have machine learning algorithms, deep learning algorithms. So we are trying to use various methodologies in order to models that we call in machine learning and deep learning, where we can collect all the data, analyze it, and then try to give some solutions for the problems that happen. If you look at it, we normally have a lot of data. We will be able to give the data to a particular model in a machine learning environment, and the model will be able to give us a set of processes that can happen out of it. This we call it as intelligence. We call artificial intelligence, right? So from the data, we are trying to gain some insights. I'll give you a simple example. Say I'll show you the next slide so that you get an idea about it. This is a prescriptive analytics infographic of a hospital. So you have the admissions by division, different types of specializations or wards, they call it: gynecology, surgery, orthopedics, and neurology. And then the admission over versus the cost over time, and the admitted patients, what are the number of outpatients. And this just gives a pictorial or a visual representation of what happened in the hospital environment. Now, from this data, this is a simple picture that we see on the screen, but the data behind it is over a period of 1 year. Okay, it is from January to December, and we have all the data that had been collected in a hospital just put inside a single picture so that we are able to identify. Now, from this picture, managers will be able to make data-driven decisions in order to increase the number of doctors in the given ward, or increase the number of beds in a hospital, because they had collected data over. And by default, we are always collecting data. This data can be used in order to make decisions. So I'll show you another slide later on. I want you to remember that data is very, very important, or whatever content we collect from the sensors or the IoT is very, very important. And from this data, we will be able to mint money if we use the data properly with the right analysis behind it. This slide shows you the operations behind it. There are certain things that generate data in them. And what are they? We have a lot of things that are used now. Wearables. I need not have to give you examples on wearables. You would all have a pulse oximeter now in your hand, in your house. If you are really worried about it, your pulse oximeter is a small IoT device. Wearables, you have the pacemaker, the fitness equipments that they have in order to count the number of steps you take. You have shoes fitted with pressure sensors that can count the number of steps you take to say whether you have done enough exercise. And you have smart watches, and these watches will tell you whether your heart rate is right. And if your heart rate is not right, it will immediately give a alert for yourself so that you will be able to monitor it. Okay, these are some of the basic wearables which is affordable, which is available in our country. Okay, and then smart jackets are also available. I have not used them, but these jackets will help you feel cool if the surrounding is hot, and hot if the surrounding is cool. You have various movable devices also coming in. There are a lot of devices that have been pervading the society in the wearable sector. Okay, cars, we have the driverless cars. Of course, we are moving into the electric vehicle setup, and the electric vehicle is an internet of thing. Okay, that has various electrical connections in it, and these, if they are connected to the internet, you will be able to easily make it work. And even all the high-end cars that are being manufactured now have a chipset available in them, and that can be programmed. And this programming, it has a server which automatically sends back information to the manufacturer in order to make changes in the way in which the car functions to increase the comfort of the user, the driver, and other various essential factors in them. Motors, buildings, mobile devices, meters, robots, generators, and there are a lot of things, our household equipment that we use, for transport what we use, and for different places that we go, there are a lot of things. And what do these things use? They use some sensors or actuators. These sensors will gather data from the environment, and the actuators will make something move around them. This is from a computer application point of view. I'm just trying to give you an explanation of it. Now, the data that is being sensed here, or the data that is being gathered here, is being aggregated together or collected, and this data is being analyzed. And we call this to be an edge if it is very close to the sensor. If the edge is not on a cloud, I envision that all of you would have a basic idea of what is a cloud. So if the data is not on the cloud, we call it on the edge. And on the edge, or a fog, is a name that computer scientists give to it. And here we do some early data analysis. It is then sent on to a data center or to a cloud IT for doing deep data analytics in them. And this is just purely software based. But remember, the software based work that happens behind on this data is something that can entirely change the way in which these things work. Because we are taking data over a period of time, we are making an analysis on it, and then we are trying to make some informed decision based on it. And your decision is based on data, so your decision will never be wrong. Okay, so this is where data generation is not only just generated and then used for a particular time, but it is being archived so that we will be able to convert this data into information or useful nudges of wisdom that can be helpful in making policy decisions later. So if you look at it, there are 3 stages of it. Well, number 1, where your thing is being networked with sensor. It can be at rest or it can be in motion, and you can have any way in which you gather that information, and the thing will be connected through either a wired mechanism or a wireless mechanism. The thing is connected onto something where it sends data back. Okay. Now, what happens is it will report it to a data store, and the data store will collect data either as a text value, a number, or a video, or an image, depending on the type of data that is being sent. Okay, this, and one example that you can take is about the Mars rover that was sent to space. So we cannot go to space. What do? We collect data from the rover, and we use a lot of sensors on them, and we analyze the data here and then make changes in the rover in order to see that it moves faster. Last week, 2 weeks back, I was hearing a lady from ISRO explain how they worked on that Mars mission. And she said that actually they had to move the Mars vehicle, Martian robo, on the surface, and they had actually gone through a particular area. But Mars data takes a lot of time to come back on Earth. So they had to wait for a long time in order to get the data back, within which they cannot stop the vehicle from movement. But then they analyzed the data and found that they had crossed a spot in which they could revisit and make some more analysis on them. So what she said was, we again went back, reprogrammed it in order to bring it back to the original position where we wanted to do some analysis, and then we took it forward. This is a policy decision. It doesn't, you cannot take this decision just like that. Just because we feel it, just because we like it, we cannot take a decision like that. But since we have a data store, we make some analysis, and our analysis is being backed up with some numbers, we are able to make crucial decisions. So in places where we will not be able to make crucial decisions, this kind of analytics normally helps. This is where Internet of Things has helped a lot of people, where human error or human fatigue will not become a problem because your machines or things do not complain. Now, what do you do with the data store that you have? Okay, this data store keeps periodically analyzing. Here you have another word that comes into picture. It is human or machine learning with various servers or cloud in them, and we call it cognition. What is cognition? Trying to understand, trying to compare, trying to link together. And it is something which is related to intelligence, which only intelligent or people with knowledge will be able to do. And this type of cognitive information is being gathered from the analytic, the data that the sensors send in, and using certain algorithms, using certain methodologies which are very simple. Okay, we need not worry that it is so difficult, it's costly in order to use AI, in order to work with them. They are very simple and easily available, openly available. Those can be applied on the data that we have in order to make meaningful decisions. And what do these analytic engines do? They give us feedback and control, so that we will be able to control the connected devices, or we will be able to make changes in the way in which they work in order to make it more suitable for the people who are around them. So if you look at the triangle, you see that the sensor or the actuator device is very small, but what is gathered from them is very big. Okay, we have one single sensor, one single thermostat, humidity sensor inserted in a field. Okay, fine, we have inserted it. Now from the humidity sensor, we are gathering some data on an Arduino board, and it's connected to an Arduino board, and then it is being sent on to the server, and the data is being logged. Fine, so I get just one single number. So every 10 minutes I try to find out what is the humidity in the soil. Okay, so this is a number that is being sent for every 10 minutes, right? Now, what I do is, instead of just storing the 10-minute humidity sensor integer value, I'm also storing the time and the date in which it is being sent. So what do I do now? I have a set of data that tells me this is the humidity at this point of time. Okay, and then after a day's time, I will be able to know what is the humidity in the morning, what is the humidity in the afternoon and in the evening. And maybe over a month's time, I will know that the humidity of over a period of time, during these times, I'm able to, the humidity increases or the humidity decreases. So if you look at it, we get a pattern formed over a group, range of values collected from one single sensor. Okay, imagine you have different types of sensors on the field, and all of them giving you data. You will have a lot of data being analyzed, and this data individually we will not be able to analyze it humanly. But thanks to the new type of devices that we have, or the technology that has been increased now, that has facilitated learning and intelligence, we are able to use these small devices in order to gather the data, and then we are able to consolidate them, and we have apps, services in them which will make management of this data possible. And finally, you have a place where all this data is being aggregated together. So it may be a single sensor, but over a period of time, it sends me GBs of data, gigabytes of data that I can use. Now, what is this gigabyte of data? Data about something which happened on a place where I want to monitor. Say, take an example of a school. Okay, this is an example of the smart Internet of Things school. Now, what happens in a school if it becomes a smart place? You will have personalized learning with adaptive e-textbooks, and in your e-textbooks, you will have something where if a student finishes learning a particular chapter, immediately information is being sent to the teacher saying that the student has completed it. If someone has not completed, the teacher knows now. Okay, so the teacher and the student are linked together. Then you have digital classroom with whiteboards and displays, and then you have a video recorder for lecture capture so that the principal can have an eye on all the teachers who are taking the lectures. Wearables for athletics and attendance tracking. You don't have to go and say yes, miss, for your class teacher. You only have to walk in through the door and automatically your RFID tag is being read and an attendance is given for you. Okay, or your facial recognition or your thumbprint is being read, and you are able to understand, give your attendance in it. Okay, and for supplies, inventory tracking by sensors with auto reorder. You have all these facilities available even in our Kirana shops now. If it's a big, small supermarket, now they have these barcode readers available. They use the barcode readers, put small stickers on them. It is automatically connected to their computers. And if there is a reduction in the stock, then immediately it is being reordered for the people to get it. Okay, so the same mechanism is being used here. Sensors on trash in order to show that it is full so that you will automatically refill the given sensor. Cleaning is done automatically also. You have robots that can go through the whole school and try to clean it during scheduled times. When the class is locked, automatically the robot will start cleaning the whole place, and the robot will be programmed completely to go to every place in the classroom in order to clean it. Okay, we have those robots available. It's maybe 30 to 40,000 on the Amazon website. But those robots, as a security specialist, I will not recommend you to have those robots in your hand. I'll tell you why later on. So the Internet of Things based monitor, you have sensors on the schools, then Wi-Fi sensors, locks, surveillance cameras, robotics. Imagine just one sensor can give you GBs of data. On a smart Internet of Things school, you will get a lot of data. Normally, what we do is take all this data, store it somewhere. If there is a problem or a break-in, we just take the surveillance video and go back to it. Okay, and we are not using the data for which we have spent a lot in order to collect this information. So what we normally do is that we try to use all this data, store it somewhere, and use it only when there is a necessity. We call it a reactive use of the given data. If there's a problem, we go back to the data, try to analyze it and fix the problem. Now, what happens in your prescriptive analytics? You try to take all this data, and there's someone sitting daily monitoring the data and trying to find out patterns in them. It may not be a human, it may be a small machine code that will run on the data in order to find out some kind of repetition or some kind of patterns that emerge out of it. Patterns or classifications or clusters that arise out of this data, which can be interpreted in order to make some decisions on the given topic. Okay, so if it is a school, this thing happens. Now, in the industry, what do we do? I would like to show you the transition that happened in the industry. This was a picture that I found out on the internet about the different transitions that happen from water power, steam power to electricity, then computers, and then cyber physical systems, which we were, and now it has moved on to the industry 5.0, where it is personalized industrial. industry working, wherein if I give you an example, it's like industry doesn't make a shirt and then try to market it now. It will ask me what kind of shirt I want, what is the design I want, and then try to manufacture accordingly. Okay, so this is called as mass customization, and it is called as personalization of information. How am I able to personalize? It is because I'm trying to analyze the data in order to find out solutions for them. So I'm trying to analyze the data of my customers, the likes and dislikes of my customers. I'll give you a simple example. You go on to Amazon and you order a bag, okay, and then underneath it you just scroll down, it will tell you those who bought this bag also bought all this. Okay, today you get a bag, tomorrow you go on your Google search engine and type something else for your search, it will show you a bag advertisement on the site. Okay, and we call this kind of system a recommender system. Now what does this recommender system do? It just does what this Internet of Things thing we have been talking about all along. The recommender system takes all the data that you enter on your Google Chrome, on your taskbar, and saves it. So it knows that Janet is going to like this kind of words, and she will only type these kind of words on her text box, and these are the links that she will spend a lot of time looking at. Even on YouTube, you see that. Okay, if you look at a video and you spend a lot of time looking at a video, similar videos will be listed underneath it. How are they doing it? This is called as data-driven decision making. No one is sitting there and saying, oh, she has clicked on this, let all these videos come underneath it. It's automatically done. This is where intelligence comes into picture. Machine intelligence comes into picture, or we call it artificial intelligence or machine learning. There is a code or a set of lines which automatically run on the data that is aggregated over my user profile in order to tag me, in order to say that this user likes these kind of informations in them. Okay, after which it is trying to use that data in order to make decisions for me, and it is trying to tell me that this video is good for you, and it's trying to make me understand it. Of course, it bleeds into another kind of problem, that is the infringement into the privacy, which all the governments have been fighting now. We will not go into those controversial topics, but we will see what is very interesting about it and how it can be tapped in order to make our workforce more secure, more interesting, and make decisions so that we don't waste a lot of time and effort on other things. So this Industry 5.0 actually is expanding of what is in Industry 4.0. Okay, the focus Industry 4.0 was on connecting the machines together. You would have heard about assembly lines, wherein many of the actions are being run by robotic arms, and then it has sensors on it. We have a bottling plant, a Coca-Cola bottling plant in NIT Trichy Mechatronics Lab in the Siemens Center of Excellence, where all the bottles will be sealed with a cap, and it will sense whether the cap is proper, the color code is proper, and the bottle is full, and only then it will seal it and it will send it automatically to a packing plant. Actually, the Siemens PLC is there, and we have a small demo unit of it for teaching our students about it. So it was focused on connecting these machines together in order to make them work, and it is about mass customization. Say I develop something and I then market it to the individual so that they will come and use it. Right, so a lot has been spent on marketing also. You have intelligent supply chain, where you have these reordering, automatic ordering because of inventories that are being maintained, smart products that are being developed, and manpower is distant from the factories. Okay, so some of them lost jobs because of the machines being put inside a factory in order to make it work. Okay. Now, what is Industry 5.0 working on is it will focus on delivering a customer experience. They say customer is a king, right? And what does the customer want? Something which is customized according to his need. A shoe that fits myself, a shoe that I can design and I can give an order to. Say I take my own measurements and I order for a dress, I get the dress that I want. Okay, it's not that I get any size that I want and I try to fit myself inside, but something that I really am interested in, which I had designed for myself, that the industry is able to procure for me. And how is this possible? Why was it not possible with Industry 4.0? Because data was not used. And Industry 5.0, I have a backup of data and I have a recommender system also that previously tells me that these are the likes and dislikes of the user. So according to the likes and dislikes of the user, I will try to manipulate whatever I have in order to provide satisfaction to the user. So it is hyper customization, responsive and distributed supply chain, where it is not focused on the warehouse, it is not focused on the factory alone, and it can happen anywhere. Okay, and it is experience activated or interactive products where the customer has more say on the product. It's not that they give you whatever you want and you take it. And it will also increase the number of people who are working in the factories in order to make them do some things that the customer wants at a particular time. And because everyone is connected, the connection is seamless and we will not have any delays in trying to produce whatever we want. So this, compared with Industry 4.0, Industry 5.0 has shifted the onus on completely to the customer, making them more in control over the products that they are designing on. Okay, and now I would like to show you some of the sensors, autonomous devices that have been used. This is an example of a car, autonomous car. You have LiDARs, you have radars, you have GPS, you have cameras, but all these have to work. So what is behind this is the software that they are using that will capture all this data from the sensors and then do a terrain mapping, do a path planning, do adaptive vision, or learn from the drivers in order to drive by itself, to know when to brake, when to speed, and how much speed should I give, which the driver automatically learns. Now, how is a machine able to do this? What the machine does is it doesn't look at only one data in order to learn. It looks at data over a period of time, over a period span of 1 year. It studies what is the way in which the human driver has done, okay, and how exactly has he done, driven, and what are the various parameters. When did he brake it, apply the brake? When did he shift the gear? What is the speed with which he went? And what was the terrain? So a lot of factors come into picture. Now all these factors are put together in order to make things happen. Earlier, we did not have the technology to work with it, but thanks to the improvement in technology, now we have the neural networks, the graphic processing units, the tensor processing units, which help us to crunch all this data together. We are able to use them properly now. This is an example of the self-driving car where the dashboard has the details of it, and it's actually a software that will run the car so that the user will only have to use it in terms of emergency in them, which is already on the road, but people are still working on them in order to make them safe. We also have the industry, and most of the industries for safety and security, or for the working of the machines which are harsh, people try to use these softwares and automatic sensors in them. I'm not very well versed with industrial sensors, but these industries, in the industries, people use a small tablet on which they do some programming in order to make those engines work or make those devices work. So the small tablet that you use have some program, and it communicates with the sensors on the big machines that are present in boilers, turbines, and other machines that are being used on welders. So they use these tablets in order to communicate to them. So the sensors are present. Those sensors keep transmitting some information and taking some commands from the control system that they have. So this is a simple Internet of Thing in working. Okay, and this is actually a pick and place robo, if I'm right, and or a welding robo. And you have various other types of machines which humans worked earlier, which are slowly being replaced with autonomous systems. This is actually a driving simulator and digital twins. You know, when you are not able to create your own system, or if it's not easy to understand how exactly a abstract concept works, we can create a digital twin of it to see if it will work in the same condition, so that we will simulate or make changes in them in order to see that it works properly. So what we try to do is, like for flight training, we will not be able to train them on airplanes, make them sit on an airplane like we make people sit on a motorbike or a cycle in order to learn. Okay, so what we do, we create a simulated environment in order to make them work. That was only for unthinkable situations like space travel. We create a simulation of the spaceship and see if the people will be able to adjust to it and make them accustomed to it. That has been translated on to the automotive industry now, wherein we make twins of the engines, the engine parts, or the working of it in order to see if it will provide with solutions for our problems. And after it works, then it is being translated on to the drawing board in order to make it feasible. So this digital twins help in terms of all types of building, shipbuilding, then car design, even watch designs. They try to do a digital twin of it to see if it will work. Any part that is not visible to the human eye, they create a digital twin of it in order to study the consequences of various changes. On research front, this digital twin has helped a lot in reducing some of the losses that normally happen. Okay, and this is an example of fully automated storage and shipping facility in Japan. This doesn't have human beings in them. It is the advantage of this facility is that your lighting is very less. You don't need lighting. It has been completely cooled and people don't go in and out. So the energy is saved, and the system inside automatically works. Now, where does human manpower come into picture for analyzing all of them in order to monitor their working and to study the strength, the health of these systems? There has to be a person behind it. That is where I told you there will be new workforce with new reskilled technological ideas and new reskilled what do you call it? Skills that they will have to learn in order to make this analysis possible. So those people will be used in order to monitor the health of them, but all of them would be based on a software. That's why people say that the software industry has been booming, and it has permeated into production, engineering, electronics, electrical, and all the other facets, because the machines which had been earlier using gears have moved on to using sensors, where these sensors send back some data that has to be processed using softwares. So for a software professional, it can easily take all the data in order to analyze it and try to understand whether the information can be used for further processing, whether some part has to be changed. So that a human being has to go in and do. So only the specific information is being given, and that part is being changed before it breaks down, so that the downtime of a shop floor machine has been reduced and we don't have any downtime at all in it. So these are some of the advantages that we normally have on the shop floor. And this is an example of the various technologies, various methods that have been used. We call it predictive machine analytics, where you have a system. So in predictive machine analytics, we try to gather all the sensor data available on the machine, and we try to make meaningful changes in them in order to see if these sensor data will provide us with information about the level of the liquid. What do you call that liquid in you'll have the greasing, no, that some liquid they'll pour in order to grease the moving joints of a given robo. Okay, so that liquid level has to be maintained. If it goes below a level, it has to be replenished, and the machine cannot automatically do it. Of course, in high level situations, we will be able to do it if it is fully automated, but we can make predictive machine analytics based on this, and we'll say what is the wear and tear of a moving part, and if the wear, coolant or lubricant. Thank you very much, Prashant. You call it a coolant or a lubricant? Yes, thank you. So you have these replacement of these coolers. When do you do it? Okay, so the data inside the machine is being analyzed and it is being automatically sent. You know, we have this hilarious situation wherein suddenly your car fuel goes down completely and you are not able to move. Okay, and this situation is normally not necessary because you will have to keep track of your fuel manually. But now we have sensors that will give us a beep sound or a light on the dashboard that will tell that it is below reserve. Okay, so this is called as predictive maintenance of a machine. Before it breaks down or it becomes a problem, you will have to rectify the given problem. And this is a proactive approach that people try to use. Industrial augmented reality. Augmented reality is, say, real along with artificial situation in it. Okay, that we call it as augmented reality. Say if you have to go inside, open a motorbike and look at the engine and what happens inside the engine, it's not possible. Okay, so what we normally do is use industrial augmented reality in order to look at the inside of the engine. We try to find out the parameters behind it and fix the parameters on the simulator and try to simulate, or what do you call it, visualize or augment the motor by itself. Okay, this is a technique that is being used in order to do all types of high risk situations, or where you cannot go inside on a power plant or in a gas turbine. You will not be able to move beyond a particular safety zone. So in such cases, we try to do this. Okay, cobots that work along with the robo. You would have seen about these pictures, these clips on WhatsApp, wherein there is an automatic Apple sorting machine. So they all use different kinds of robots on a conveyor belt in order to work. This has been there for a long time, but these cobots, if you add predictive machine analytics to it and industrial augmented reality, there will be a value addition to it. Okay, and you have modular equipment that can move by itself, maybe a drone or something. You have blockchain for enterprise resource planning and supply chain management. What is the advantage of blockchain? It provides you with security, and you will have a common, it's just like a ledger that you use in your industry, and the ledger is being shared by everyone and everyone knows about what is inside it, and it is also it is within a closed group. Your blockchain will act as a data store that will ensure transparency in it. Computer vision, it has gone some a lot now, which earlier we only used to do 2D computer vision, and now we have depth sensing cameras also available, and these depth sensing cameras will get a 3-dimensional view of an image. And now we have this 360-degree camera also available. Like you take the 360-degree video and you just turn it around, you will be able to see the other side. You'll get a 360-degree view of whatever is present inside it. We are slowly moving on to what reality and argument can combine together in order to do, and that is being applied on to various problems and we are trying to give the human eye onto a machine in order to make it work. That we call as computer vision. We have unmanned trucks that can move over a particular place in order to load or unload where it is not very safe for a human being to be in. We try to use these unmanned vehicles in order to do it. And wearables, we have these devices on the people in order to make things easier, increase safety. You have a helmet with a camera on top of it for this American SEALs who went to fight in different situations. Every movement of them has to be captured on a camera. So they will have a headband in which there will be a light and a camera attached to it, and all the information will be captured and it will be transmitted. That is a simple wearable. The shoes that you wear, and if it is very hot and you're not able to know it, the shoe will tell you. So anything can become smart. Your smart jackets for people in the glaciers of the northern India, the soldiers who are there in the Kargil, they have their own smart suits that they wear in order to withstand the harsh conditions around them. So your wearables, depending on the industry, depending on the place where you are and what is the environment around you, you try to put in those kind of sensors in them in order to make it possible. Okay. And this is an example of a smart factory. So you will have robots in them. You will have, this is a robot. This is a cobot that works along with a human. And then you will have people working with systems. There will be servers in them. There will be vehicles that will transfer itself, manned vehicles, unmanned vehicles, drones available. And you will have people who are trying to research. So everything works together, and these computers become a part of them, and all these are said to be programmable. So you write the program that is needed in order to make it work. Okay. This is an example of what I gave you. Now, coming to the last part of it, I just want to give you a brief overview about the security, because Internet of Things, I told you initially that people were worried about it because of the security problems behind it. Say you have a car and the car locks and unlocks itself by a press of your cell phone. You're very happy about it, okay? And you drive your car everywhere, and even from inside your office, you can unlock the car so that someone else will come and open it and you will be able to get into it. Or as soon as you want to get inside the car, you say that you are going to come, and the car switches its AC on so that the climate is, the temperature is conducive when you step inside the car. It's very happy. You get a lot of comfort out of it. Fine. And you keep driving along the highway and suddenly your car stops. Okay. And you try everything that is possible in it in order to start the car. Your car doesn't start. Why? Someone has hacked onto the software in it and they have locked it. Now, if you switch on your cell phone, you get a message in it saying that you will have to pay this much amount in order to restart your car. It's happened in real life. Okay, and this hacking can happen anywhere, and this is one big problem in a house too. Okay, you have a house which has been completely smart, smartened, like adding sensors so that your light switches on whenever you walk inside the room. When you walk inside the hall, the TV comes on and you're able to look at the video that is displayed on the TV. It's so comfortable about it. You are very happy about it. But remember that this data can land up in the wrong hands if the security is not proper. If the information that you have taken is not proper, it can hand up in the wrong hands. People can, the person who has hacked your house will get all the data that you collected, and then they will know what time you enter inside the house, what time you leave early in the morning, so that they will know when they will be able to come into the house in order to break it. This is personal data which you don't want others to know, which automatically goes out. This is called as the privacy issue, and this has been a big problem with vehicle hacking, global positioning system spoofing, healthcare device and information hacking, industrial hacking, smart home hacking, transportation safety. Even our power grids went down, and that was also because of hacking. In Kudankulam power plant, people hacked inside. They said that it was outside the network, but we do not know because it was another country trying to hack into the data. Okay, so this type of security breaches keep happening. Even in our banks, you have an online account and you are able to transfer it. Your banks, your ATMs were the initial IoT devices that came in. And these ATMs are connected to the servers, but now people are pushing us on to online transactions that have to happen, right? But what happens when these the online systems are being hacked? We get into a problem. This security is a big problem, and people have been working on various protocols and various methods in order to make the transactions and the data secure. So once that is taken care of, we will be able to work with all types of systems. Till then, the general systems in which security is not a high point of view can be used, or it should be within a closed network which has no contact with the outside network. So this is an example of how someone can take control. They can take control about your doors, locks, or lighting systems. They can steal your information and use it in order to analyze you or get to know more about you, or simply they'll just disrupt your service so that you are not able to work with it. Okay, and they'll try to add more data to you, or try to remove some data from what you have, or try to send you a wrong information in order to maliciously make changes in them. Where are we in this? Okay, if you look at the number of installed IoT devices around the world, the number of devices have been increasing a lot. And now with lockdown, each house has one laptop per person for us to take classes, for us to do our work and all the others. Okay, some of the major challenges that IoT technology is facing is that developers are rushing with products which are not properly secure. This is why I gave you the previous slide. The developers claim that a lot of things can be done, but without proper secure features. For example, they had a baby monitoring system wherein the baby is made to lie down on a crib. Normally in India, we have the mother or some sitter sitting next to it, or some old person in the house looking at the baby. Okay, so where people are not available, they try to find out baby monitoring systems that will monitor the baby to see if the baby's eyes are open. And those systems were hacked because the developer did not think about security at all. And what happens in such case, some pertinent information is being leaked out and someone else can gain access into the network. If your baby monitoring system is connected to your network, your computer, your personal home computer, the hacker can hack through the baby monitoring system and through the lead get into your computer and take control over your computer. Okay, so this is where a lot of ransomware attacks happened. Even in the European countries, their hospital system came down 2 years back. That was because of this kind of an attack that happened on an ICU unit that they had installed an IoT device through which the hacker gained control into the entire system and disrupted the working of it. Okay, so companies that will not benefit from IoT from lack of data science specialists. If you do not know the importance of the data that IoT brings, you are not going to use it at all, and you just leave it. But if you can spend a little more on these data scientists, you will be able to use that data in order to reduce a lot of information redundancy that you use. We keep collecting data every time. You want something, you just collect data from everyone. We are wasting a lot of time, effort, and energy in order to do it. So if you have a system in place, a set of devices and an analyst, he will be able to provide you with whatever data you want, and you will be able to get results from it. Okay, and some of the IoT products on the market are vulnerable to attacks. Not only Americans, Indians never update their firmware at all. We don't normally click updates. Now Windows makes it mandatory that we'll have to update it, so we keep updating it. And this lack of updation makes us open to all types of security attacks. And rural areas lack reliable connection. Of course, we are doing well now with the Prime Minister opening it up to all the different types of people who, so that we will be able to connect even to the remote villages. With the last mile connectivity, it has been increasing now. Okay. So some of the this is from an industrial perspective that they have given. And what are the various operations that happen, okay, that IoT helps us with? Remote operations, where you do a work at home. Say I am at home, you are at home, and many of us are in different places, but we all come together with the help of this beautiful platform. Okay, and I have a camera, and there are a lot of devices that I have used in order to make this as seamless as possible. Artificial intelligence IoT, which uses the intelligence, which uses the data in order to gain or gather information to it. Medical care, we see that it has been pervaded. Even your pulse oximeter that you put on your finger now, it is a device, and with that device you can happily sit at home now. Or else every time you feel breathless, you'll have to run to the hospital. Okay, so this device has put a lot of people under home quarantine now, or else our hospitals would be overflowing now with people who just need to have their finger in the pulse oximeter. I hope most of your households would have that device now that COVID is increasing around us. Okay, that device, steamer, so all those which we never thought about, which we thought only would be available in a hospital, now we have to buy it and keep it at home because it has become a necessity. And in the future, Internet of Things would also become a necessity. That is why the researchers are working on various protocols and standards in order to seal the breaches that can happen to make it more conducive and secure. Sustainability is provided. Edge computing, wherein on the sensor itself, they give intelligence to it. Okay, on the sensor, it will be a neuron, and it will sense data, and it will make decision on the sensor itself. Instead of sending the data to the cloud, from the cloud it does the processing and sends back the data to the sensor. They are trying to make smart sensors, which sits on the edge itself. Of course, it makes the edge a bit with the memory and some things. And if you take an example of it, your Arduino board, your Raspberry Pi, they are all edge devices that you can use. Okay, your Arduino is a bit costly, your Raspberry Pi is a bit costly. Arduino is cheaper than the Raspberry Pi that we use. Hyper automation, smart cities, smart food production, blockchain, resilient business. Blockchains is about database and about storage of your information, so that a peer-reviewed set of people will be able to use that. Okay. So this is all I had to talk about how IoT influences us and how the various facets of data, the data that we use, the data at rest, the data in motion, can be used in order to make meaningful decisions, data-driven decisions possible, so that we will be able to provide with solutions or think about problems even before they happen, and try to provide with measures where we can fix them. Okay, so this is where the intelligence plays a role and analytics plays a role. IoT is not only about the sensor, connecting it to a board in order to make it work. Thank you very much for your listening, and thank you very much for the answers that you gave on the chat. If you have any questions, I want you to give me a few questions so that I will be able to explain it to you.
Thank you, ma'am. That was a wonderful talk. It was seamless, and I could see the high energy in the voice that you carried throughout the 1.5 hour session. It was really wonderful when we were planning for Industry 4.0. You have now said Industry 5.0 is already there and it is being implemented. And you gave some very lively examples in the bunion business or the t-shirt business, where it gets customized to the name. And I'm sure people are experiencing quite a few things. In fact, you have also given us the alarm of where all our things are being, our information is being caught. Quite a few of us own the Alexa. Many people have smart TVs. The minute you have a smart TV, people think that I don't switch off the TV, it's okay. But many of your smart TVs can actually take your voice and change channels. So there is somebody there who's actually listening to your smart TV. You don't need any other device which can capture your private information, especially in the living room when you're chatting with your family members. So you have given us quite a few insights on how to be careful as well. I would request the audience, if you have any questions, especially she's covered quite a wide range from the way the sensors are, where the IoT devices, where they're put in place, how they are integrated, how the data is collected, analyzed, and how we have gone to predictive analytics from the other regions. So yeah, I find one question here. You can unmute and ask also.
Madam, good evening, madam.
Yeah. Yes.
Madam, my name is R. Karthikeyan.
Okay.
Madam, can you give some idea about data losses during poor weather conditions?
Data
Losses.
losses.
Data losses
LOSS.
LOSS during poor weather conditions.
Okay. During poor weather conditions, you have data loss. Can you explain what is this with an example of how exactly, what type of sensor and what type of data it's collecting?
Yes, madam. Actually, old person who is suffering, who is staying in a house, smart house, needs some medical assistance during some poor weather conditions.
It's not poor weather condition. Even if your connectivity is not good, then you will have a data loss. But for such conditions, if we have an edge device and the edge device can make some decisions on it, then we will not be losing out on the data. If you are fully dependent on your data going out to your doctor and getting back, or to a server and getting back, people find it difficult. That is why your fog or your cloud computing did not take off in these critical applications. Say healthcare, and those are said to be critical, and you cannot afford to lose time over it, and you cannot wait for it for these data losses. That is why the shift moved on from fog computing or cloud computing on to edge computing, where on the device itself, we try to give them intelligence in order to make some simple decisions. Normally for elderly people, it's like if they had fallen down, if there's no movement for a particular interval of time, you will have to immediately alert. Okay. Yes. So for those conditions, we will automatically do a programming on the edge device itself, which is inside the house, for which you don't have to wait for data to be lost somewhere.
Yeah. Thank you, ma'am. Thank you.
Yeah.
Minimum requirements of storage capacity of IoT. IoT is very general. What do you mean? Do you mean the sensors, Suresh? You had asked about the minimum requirements of storage capacity of IoT. What do you mean by it? Do you mean by the on the device, or on the cloud, or on the fog? Minimum storage capacity is you don't need any storage at all for your IoT if you are just connecting it to a device in order to send your information from that. If it's a sensor, the sensor will have to take the data and transmit it. Okay. Now you have boards, you have a Arduino board that doesn't have any memory in it, which you will have to connect onto your computer, or you can have a Raspberry Pi that comes even with a 4 GB or greater memory card attached to it. So you can, depending on the type of storage, you can increase, you can have your own pen drives with external memory in it, which is programmed, which can be accessed on your board in order to make it work. There are also customizable boards and industrial boards available. Depending on the sensor used, depending on the data that is being processed on it, the data storage capacity changes. But now with the small, the reduction in the cost of data storage, a lot of data has been, And a lot of GBs of memory have been available to us. Even on your cameras, you have cards that have high storage devices available in them. That can be an edge, but it is not intelligent unless you make some processing available to it or put in a model inside it. Yeah. Any other questions?
Very interesting. Yeah.
Good evening, madam. I am Albert Stephen from RANE Polytechnic. So I want to know the difference between Industry 5 and Industry 4. You told in Industry 4 data are used, and Industry 5 data are used. So in Industry 4, actually they are not at all using any data, madam. And I want to know more about the hyper customization and the mass customization. In that area, you can explain something.
We are trying to gather data from the customer. We are trying to find patterns in it, and we are trying to produce our products according to the customer. See, take an example. Reliance Industry used to make some garments, send it to the Reliance Mart so that we would be able to go to it, try to shop it, and get it from them. Okay. Now, what they are trying to do is they are trying to map all the customer buying patterns, understand what is the customer buying pattern, and then try to find out what is the likes and dislikes of the customer and give a particular design for a customer. And if you like the design, you place an order and you get it shipped directly to it. Okay, so the logistics changes, the way in which it works changes. So this becomes, personal marketing. So individual marketing to a person, and for each individual, you are trying to sell it according to their own needs. So the industry doesn't mass produce, but it produces according to the whims and fancies of a group of people, not just individual people.
That was a wonderful example. In fact, Tesla as a car, the electric car keeps collecting information from the individual users, and the firmware of the car keeps getting updated in periodical intervals. So I am told from some of the owners, Tesla owners, that they even fine tune it to the way in which you press your brake or press your whatever clutch and all that, so that next time, even when you apply a little pressure, it actually helps. That kind of a customization is actually coming through. And one more interesting story I heard from a friend of mine who lives in the UK, and they live in a small township kind of an area which has got forest area around. It seems that the elderly people are fixed with what is known as some location RFID device kind of a stuff, which gets transmit signals all the time. So there was a person who had Alzheimer's and who forgot his way and got into the woods. The minute after 2-3 hours, they found that the person has not come back. The police went inside the woods, traced the person, and brought them back. So to that extent, they have these kinds of sensors working and put to very intelligent use, not for just, trying or not for just certain other things which commercial organizations use, like say Reliance or Tesla, where they increase their marketing power and want to sell more. They're putting it to good social use as well, where they're helping elderly people. Yeah, somebody has written, is Runu Tuntube has written, hyper customization works mainly for high-end customers. Mostly, yes. I think she's right anyway.
High-end customers, the middle class are slowly becoming the high-end customers now, thanks to all these kind of intelligent, technologies that come in. We are also given more powers in order to become that. So that's yes, madam.
Yeah. There is, complete this. We'll go to there is a question before that, and with that, I think we can close the session also. Yeah.
So hyper customization, it includes a lot more people when the middle class comes in. So that has a lot of scope for analytics and for giving results in that. IoT sensors don't have memory. Then how device level security is being handled, it makes them vulnerable all the time, depending upon manufacturer also. IoT sensors, some of them have memory. Okay, it depends on how it is being manufactured and why and for what use it is being manufactured. and they have their own protocols now. We have wired WPE, which is privacy for wireless communication between them, and those have a set of protocols that are being developed now in order to make it possible. Okay, so it is vulnerable, and if we as knowledgeable users use the right system, we will not be exploited by the hackers. And if it is not a high end or a high risk situation, we can afford to use the sensors that are available with a few security measures in the software plane, so that the device does not get hacked.
One last question from my side, could be selfish as well. So this Internet of Things laboratory, which is there in NITT, is it only for NIT students, or could there be any small ideas which even Polytechnic students can take up as their projects for IoT related projects? This is a selfish question from my side, because we definitely have to up the ante.
Internet of Things laboratory actually in Siemens Center has the Datanis platform. The Datanis platform is a proprietary platform that had been developed for the Siemens PLCs that they had created. And in order to give the students an idea of how these, I told you about the Coca-Cola bottling plant that was present in the mechatronics lab. It is linked to that bottling plant. So the data from that is being added on to the Datanis platform, and we will be able to visualize and we will be able to see. So this has licenses to the software. If a student is interested in visualization or processing, I can give them remote access so that they will be able to, after due permissions, because I assume that RANE has a MOU with the Siemens Center of Excellence.
Yes, RANE Polytechnic has an access.
Yes, the students can take up projects, and remote logging in is possible now, because we are under COVID and physical presence in NIT will not be possible. So you can remotely log in and gain access to the software, or we can have a webinar where the lab in charge would be explaining the various facilities that are available. And once lockdown or the situation gets conducive, students can also visit here for a 1 month project or a 1 week project, or one depending on their time schedule, they can visit here and try to get their knowledge enhanced.
That is wonderful. So make note of it, Kadiravan, the HOD of mechatronics. So I'm really thankful. I'm not sure how many of them are from other polytechnic colleges or engineering colleges. So,
Madam, the Siemens Center not only has the IoT lab, there are also KUKA robots, welding robots, CNC machines, 3D printers, and there is a power electronics lab. There are other labs also available which the students can also use. So it's not only on mechatronics and IoT. There are more than 10 labs available, 12 if I'm right. So all those labs have machines with simple prototypes in them. So for students to better understand the machines that they are working with, we have some prototypes which of course are Siemens proprietary, but students can still learn from them.
Yeah. When things improve, we can probably attend these half-day training sessions which they conduct for both the faculty and the students. Thank you so much. I think with this, we have come to an end of this session. I hand it over to the principal for giving the vote of thanks. Yeah. 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 Yes. Yeah. Yeah. One small applause at the end. We touched 100 because 64 people had logged in the Meet session, and we had more than 35 people on the YouTube session as well. So I think that was a wonderful thing. Almost we maintained the audience from the beginning till the end. Thank you, Dr. Janet. Thank you all. Yeah.
Thank you, sir.
Yes. Sure.
Okay.
Thank you so much.
Thank you, ma'am.